So now screen is visible, please. The question 1 is visible. Okay, thank you. So let us start. Maybe in between participant will join, will not wait. So so question 1 is, which of the following, today we are going to solve the week 3 assignment. So one of the announcement I want to do, actually in the previous week 2 I have did only 1 hour the live session. After that I have recorded another hour and I have merged both hour and saw you can see from the lecture from the Excel sheet or YouTube channel. So now let us move with the week 3. So question 1 is, which of the following is an intensive property? So option A, mass, density, volume and energy. So you have 4 options. Please just try to write your answer in the chat box. So let me just open the chat box. This is a chat. So you can write here. You can just turn off your microphone. So because this sound will recorded by the devices. So yes. So now you can just type here. Okay. So you are typing. So you are telling the density will be the intensive property. Okay. Yes, definitely. Why? Because what is the meaning of intensive property? The definition of intensive property is, so here you can see very clearly the solution. An intensive property is the property that is independent of size or amount of the system. Intensive property remain the same regardless of the quantity of substance present. Now, example of intensive property include the temperature. So whether you have this much amount of, let us suppose, iron and this much amount of the iron, no meaning if you are the means if you, when you will heat, the temperature you feel in the same way. So another, the pressure, density and the specific heat. The meaning of this, the intensive property, if let us suppose you are heating this that much amount of the iron, so when you will touch here, the similar amount of temperature you feel, the similar, when you will touch here, similar amount of temperature feel, means after the complete heating, not the initial stage. So this is the intensive property. And what is the extensive property? This is very important concept when you will go through the Reynolds transport theorem and all. The intensive property is the property that depend on the size or amount of the system. For example, intensive property include mass, volume and total energy. So hope you understand. So now let me just reduce the thing, so this will be also recorded. So we are in the chat. This is the chat. Yes. So the next question is, next question for 2 marks. Okay. So identify, or let me just put here. Okay. So identify the statement below the choose the correct answer. So here you have the two statement. Statement 1, Reynolds transport theorem provide a link between system approach and control volume approach. Statement B, a control volume focus on a region of space. So here you have code. Option A and B are true. Option B, A is false and B are true. Option C, A and B are false. Option D, none of them. So you have four options. So please just try to understand the question, just read very carefully and try to write your answer in the chat box. Question number 2. So I think you have. Okay, okay, it is not visible. No, it, it might be visible. Oh, why it is not? Let me just open the chat. Just type again, please. Let me just see. Just type. What is the problem? The problem should not be like that. Just type, please. Have you typed or not? Oh, but it is not visible from my side. Okay, okay, that's fine, but I am just checking why it is not visible, because this is maybe technical error issue. So I'll just, yeah, it is visible. I think when I am typing, it is visible. Oh, your option is also visible. A and B are true. It is visible. Hope I think you are able to see now. A and B are true. Okay, okay. So actually I have two screens. So another screen I have put it the question, and another is, and the one screen I have put it this one, the link one. Okay, so yes, yeah. So option A is correct. That is good. So what is actually the Renault transport theorem? So it provides the necessary link between system approach and flowing a set of particle and the control volume approach, analyzing the flow through a defined region of space. Additionally, a control volume does not focus on a specific region of a space where the flow can flow in and out. So actually I want to explain here a little bit about the control volume approach, or the your system approach. The system approach means what, or you can say the Lagrangian approach. Just I'll explain from a very simple example with river. So if you are going to measure the flow velocity in the river, and you have two device. One device you have the floating device, for velocity measurement. Another you have the fixed one. Means this device you can fix at a place and you can measure the velocity. So when you are going to measure the fluid velocity using system approach, it means you are going to track a set of particle, or you are going to track the particle of the fluid. Means if you are tracking this particle, when the particle is reaching at this place, so you are tracking the same particle, you are tracking same particle. Means when you will put here your floating device, so your device will flow with the fluid velocity, or same, or keep in touch with the same fluid particle. So your device will measure the, means as water will flow in downstream, your floating device will flow in the downstream. It means you are measuring the velocity using the system approach. When you will go, what is the your control volume approach? Let us suppose you are fixing here the one instrument. You have fixed the instrument here and you are measuring the velocity at a particular point. Means the water in here and water out here, water in and out, but you are fixing the instrument and measuring the velocity. So this is the difference between your control volume approach and the system approach. It's very conceptual question. So in future you will get the question, so remember please always. So based on this concept you can get the question in final NPTEL exam or your assignment also. So now let us move on the next one, question number 3. So question number 3 is, identify the statement below. Hello. Hello, Rajkumar. Yes, no. I think Rajkumar has opened your. Just please unmute. Just please, Rajkumar, just mute your voice, please. Just mute your mic, please. I think let whether I. Yes, I am able to mic. Okay, I have muted the mic of Rajkumar. So now let us move on the question. So question 3 is, identify the statement below and choose the correct answer. Statement A, a control volume focus on a set of fluid particle. Statement B, a control volume can be fixed, movable or deformable. So you have the 3-1. So just please try to write your answer in the chat box for question number 3. So for question number 3 you are telling option A is false and B is true. Okay. So let me just see. Okay, yes, A is false and B is true. So maybe option which one correct? C option is correct for this question. So yes, your control volume may be fixed, may be movable or may be deformable, but it should be the volume. I think sir has explained very well about it. So you please go through the lecture also. I'll recommend you to understand such type of questions. Now let us move on the next one. So here let us read the explanation. The statement A is incorrect because control volume focus on a specific region in space through which fluid flow, not a set of fluid particle. A set of fluid particle would be described by a Lagrangian approach, where a control volume is described by the Eulerian approach. So please remember this explanation also. So now let us move on the next question. Question number 4. Okay. The continuity equation is based on the conservation of energy, momentum, mass and force. So this is very easy question, but I need answer from your side please. So you please just, everyone please just write your answer in the chat box. So the continuity equation is based on the conservation of whether it is energy, momentum, mass and force. Okay, you are telling the mass will be correct. So definitely I will not take much time here. That will be mass. So explanation we can see. So the continuity equation is based on the conservation of mass, which is the fundamental principle in physics, starting that mass cannot be created nor destroyed within a closed system. The continuity equation is particularly important in fluid dynamics and describe how the mass of the fluid remain constant as it flows through a given volume. So hope you understand. Now let us move on the next question. Little bit calculative. So question 5 is, what enters water enters a nozzle with a velocity of 5 meter per second and exits with a velocity of 15 meter per second. Just remember, 3 times more. The mass flow rate of the water is 10 kg per second. What is the force exerted by the water on the nozzle? So here you need to calculate the force exerted by water on the nozzle. So please little bit calculate, we just try to calculate, you have 2-3 minutes. So within 2-3 minutes just try to calculate and write your answer very carefully. Very simple one. Anyway, I have the answer, I will show you. So please just try to write your answer. I am waiting for the answer. Okay, so you are telling the 100 Newton, means option B will be correct. Okay, what about the Rajkumar? I'll wait 1 minute more for other participants, because here we are discussing. So here suppose to you just solve the question and just try to write your answer. So this is the main aim of these kind of sessions. So you have to solve, and if you are not able to solve, then I'll show you the answer and discuss the questions again. So I'll give 1 minute more for other participant. Okay, so let me just show you the answer. So here you have nozzle. Nozzle shape is like that. So here water entering with the 15 meter per second and water going out with the 5 meter per second entering and out 15 meter per second. And the enter of mass here 10 kg per second. Now what will be the force exerted by the water on the nozzle? So what will be the force act here? So now very simple one, that will be 100 Newton. So you are correct. So using of the conservation of momentum principle, so the force is equal to your rate of mass into V2 minus V1. So this will be your 10, 20 minus 10. So you will get finally 15 minus 10. Sorry, not 20. The value is 15 and 5. 15 minus 5. So 10 into 10. So finally 100 Newton. So very easy question, but conceptual. So remember please. Now let us move on the next one. Question number 6. So consider a steady incompressible flow through a converging nozzle. If the cross-sectional area at the inlet is A1 and the outlet is A2, with A2 is less than A1, remember, and the velocity at the inlet is V1, what is the velocity at outlet V2? So remember, the here condition is given steady incompressible flow. So please just try to write your answer, which option will be correct here, whether option A, B, C and D. So please just write your answer for question number 6. So again I will give you the 2-3 minutes. So please just try to write your answer. for question number 6. Very simple one, just think about. Okay, you are telling the option B is correct. V2 is equal to A1 by A2 and V1. So Vedans is telling option B is correct. Okay, so let me just check whether B is correct or not. So here definitely you have to apply what the conservation of mass. So what is conservation of mass? Yes, definitely. So A1 V1 is equal to A2 V2. Why we are applying here? Because the flow is incompressible. Study, flow is incompressible means what? If the flow is incompressible, your density will be the constant. If that flow was compressible, then here you need to write rho 1 and rho 2 also. But this is incompressible, so both will be the constant, so cancel out. So the question is asking about the V1. The question is what is the velocity at outlet V2. So V2 is A1 by A2 V1. So this will be your correct one. Very simple, but you need to know the concept, what is the mean of compressible, what is the mean of steady. So you have to understand the three-dimensional continuity equations also with full steady, unsteady. So you will remember that equation. So definitely that will be help you a lot. So here option B is correct for question number 6. Now let us move on the next one. So here explanation slightly given, so I'll read for you. Okay. So what is the detailed solution? For an incompressible and a steady flow, the conservation of mass continuity equation state that the mass flow rate must remain constant. Mathematically, it is given by rho 1, rho A1 V1, rho A2 V2. Since the density is constant for incompressible flow, it simplify like that and you can very easily write here. Now let us move on the next one. Question number 7. So here, which term in the Renault transport theorem represent the net flux of a quantity across the control surface? Which term in the Renault transport theorem represent the net flux? Remember please, the question is asking about net flux of quantity across the control surface. Local derivative term, convective term, source term, dissipation term. Which will be the correct one? So if you have seen the lecture very carefully, then you can give the answer very easily. Otherwise it will be very difficult to give the answer. So I'll give you 1 minute or 2 minutes you can take also. If you not know, you can just Google. So you will remember for a long time. So if you not know, then Google. Otherwise you just think and just try to recall your concept and try to write your answer please. Okay, so you are telling the convective term. So yes, the convective term is correct one here for Renault transport theorem. So option B will be correct for the question number 7. So let me just read the detailed solution. So the Renault transport theorem include three terms. One is a local derivative term which account for the role of change of within the control volume. The convective term which represent the net flux of the quantity across the control surface, and additional source or the sink term. So remember, very basic understanding. Now let us move on the next question. Question number 8. So question number 8 is, in the context of Renault transport theorem, which of the following statement is most appropriate? In the context of Renault transport theorem, which of the following statement is most appropriate? Option A, it uses fixed control volume. It does not use control volume approach. It links system and control volume approach. Option D, it uses deforming control volume. So just try to understand how the derivation sir have derived in the class, the recording class. Just try to write your answer in the chat box. Very conceptual question. So if you have gone through the derivation, then definitely you will be able to give the answer. So please just write your answer. So you are telling option C is correct for this, right? For question number 8, option C, it links system and control volume approach. Yes, definitely it is correct, as we have seen in the previous questions also. That is maybe first or I think second question. So the detailed solution, Renault transport theorem gives the relation between system equation, that is option C here is correct, the system equation and the corresponding control volume equation, which relate the change in extensive property of the system and control volume. Let us move on the next question. Question number 9. This question you need to read very carefully. Question 9. Let B denotes an property of a fluid. The statement of Renault transport theorem is the instantaneous total change of B inside the, here you need to fill the blank, inside the fill the blank is equal to the instantaneous total change of B within the, here you need to also fill the blank, plus the net flow of B into and out of the, here also you need to fill. You have the 3 filling the blank here. So very interesting question. This is again from very fundamental of the Renault transport theorem. So if you have gone through, then definitely you are able to give the answer. So please just think, read question first very carefully and try to recall your concept, whatever you have learned from the previous week, from your video lecture. So please just try to write your answer in the chat box. Okay, so you are telling option D, control mass, control volume, control volume. Okay, so instantaneous total change of B inside the, you are telling control mass is equal to the instantaneous total change of B within the, you are telling control volume, plus net of, plus the net flow of B into and out of the, you are telling control volume. The D meaning is this. Okay, let me just check the answer. So whether you are correct or not. Yes, option D is correct. So remember please. So you can fill in the blank like that. Control mass, control volume and control volume. So here the detailed solution I think is given. So let me just read. So the Renault transfer theorem state that the instantaneous total change of B inside the control mass is equal to the instantaneous total change of B within the control volume plus the net flow of B into and out of the control volume. So this is correct. Now let us move on the next one, question number 10. So question 10 is, let momentum be the one of the extensive property B of the fluid flowing through a nozzle. The corresponding intensive property beta of the fluid will be mass, velocity, acceleration, density. Which option will be correct? The corresponding, remember please, here just think, you have the momentum, one is the extensive property which is depend on your mass, the fluid flowing through a nozzle, the corresponding intensive property which is not depend on your mass or the shape of the body. So what will be the intensive property? So the question is like that. So first here you have to think what is B and how we will calculate the beta. So this is also important. So what will be the correct answer? Okay, anyway, I am waiting for 1 minute more. Okay, you are telling the velocity means option B. Okay. How option B is correct? Let me explain you. So momentum means what? Momentum here is represented by B, so it is nothing but mass into velocity. And what is beta? Beta is which is not depend on mass, so you need to divide this extensive property with the mass. So mv divided by m is nothing but v means velocity. So your velocity will be the correct answer. Hope you understand. So detailed solution is, let me just, okay, here the explanation is given, very long explanation, so I will not go into detail. So this is the basic fundamental what I have explained. So now this is 2 marks question, so you have to read very carefully the question. Consider the below figure. Let me just show you the figure also. Oh, where is the figure? Oh, this is the figure. So anyway, I'll show you the figure in the last. So consider the below figure, or I can reduce the size so you can see. Okay, now it is visible. So consider the below figure. The diameter of the inlet pipe 1 and outlet pipe 2. Here is inlet pipe 1 and inlet pipe 2 of the tank given 5 centimeter and the 7 centimeter respectively. The water flow of 0.01 meter cube per second through another pipe. From here you can see. Okay, pipe 3 is entering the tank. Okay, the velocity of water at the inlet pipe is 2.2. If the flow is assumed to be steady and incompressible, the velocity of flow at the outlet will be very simple question. So but you need to understand the thing. So just try to write your answer please. In the chat box you have 3-4 minutes for the calculation also. So please, I'll recommend you just try to calculate if you are looking, because here I have not joined the many students. So if you are looking this video after the recording on YouTube, you just pause the video and try to solve by yourself. Very simple question because this is. So just try to write your answer who have joined here. So I'll give you 2-3 minutes, or you can take 5 minutes also if you are not able to solve within short period. So I am waiting please. Once you will solve here the question, that will be benefited for you. In exam you can solve very easily such type of questions. So please here just try to calculate. If you are looking on YouTube, so also you just pause the video and try to calculate by yourself if you want to learn. Otherwise the many things are available nowadays. You can just type the question in the Google or share the screenshot in the Google. You will get the answer very quickly. But this is not way of the learning for any subject or any questions. So I encourage you, please try to solve by yourself. During solving such type of question, you learn the many things, how to deal with the questions and all, how to approach the new questions. So these are very important points. Okay, so you are telling 3.72 meter per second. So let me just show you the answer. So okay, option here is 3.32, 3.87, 3.72, and option D is 3 point. Well, let me just give you a bigger one. Yes, 3.52. So your answer is 3.72, which is option C is correct, and you are also telling, so you are correct. How? As you know, the discharge. So in is how much? Your Q1 plus Q3 is in and out is Q2. So this is a simple concept here. Now what question is asking? Question is asking the velocity of flow at the outlet, what will be? So question, discharge is what? Area into velocity. So velocity is discharge by area. And what is area? Area is pi by 4 d square. So this is area. Now, so discharge is what? So Q3 is given, here is Q3. Q3 is given already, which is 0.01. And what about the Q1? Inlet pipe velocity is given 2.2. If inlet pipe velocity you have, so area is pi by 4 into d square. So what will be the d? D is nothing but 5 centimeters. So you can put in the meter, 0.05 meter square into velocity 2.2. So from here you will get Q1. So you can put here the Q1 value, and after adding you will get the Q2. So very simple one. And once you will get the Q2, it is nothing but area into velocity. So A2 V2, and V2 will be Q2 by A2. So very simple, just the balance of discharge. So we'll get V2 is equal to 3.72. Now let us move on the next one. Question number 12. So question number 12 is, a cylindrical tank of radius 1 meter is filled with water up to a height of 2 meter. Water is being pumped into a tank at the rate of 0.1 meter cube per second. Calculate the rate of change of mass of water in the tank. Assume the density of water is 1000 kg per meter cube. So please just try to calculate this question. Also you have for this question 5 minutes, no issue. Okay, you are telling option A 100 kg per second. Okay. So how it is? The Renault transport theorem. But question is very easy. You can solve with general understanding also, but how you will apply the Renault transport theorem? Because if you will apply a Renault transport theorem in such a very easy question, then definitely you are able to solve the big question, the more complex question using RTT, Renault transport theorem. So let me just show you what is the Renault transport theorem. This is your mass of system is equal to change in del by del t integral control volume rho v dv, and similarly here you can see the control surface, the integral control surface rho v dot n and ta. So this is your the final expression of the Renault transport theorem. Means you are converting your system approach into control volume approach. Now the question is very easy, no issue. The rho, where here the rho is the density of water, dm system by dt is the rate of change of mass within the system, and what question is asking? Question is asking same thing, calculate the rate of change of mass of water in the tank, or you can say in the system. So question is asking these things, and Cv is control volume and Cs is your control surface. So very easy. Now V here is the velocity of the fluid across the control surface, and n is the unit normal vector to the control surface. So these are the details about this equation. Now let me just show you the answer. So in the question these two things is given, density of water and the volume flow rate, or you can say the discharge is given 0.1 meter cube per second. So here you can write very easily, discharge is what? Meter cube per second, means volume by time. So change in volume with respect to change in time is given 0.1 meter cube per second, because in the question you are telling, what question is telling? The what water is pumped into the tank at the rate of 0.1 meter cube per second, means here is the rate is given. So direct in the question it is given del v by del t is 0.1, means at 1 second you are putting 0.1 meter cube per second, another 2 second, the next second you are also putting 0.2 meter cube per second, but cumulative here is 0.2 meter cube, then again is similarly 0.3 meter cube, then 0.4 meter cube, means 0.1 meter cube you are increasing as time is increasing, 3 second, 4 second, like that. So that's why it is del v by del t. Now therefore the rate of change of mass in the water tank is what? Rho del v by del t. So you can get very easily 1000 0.100 kg per second. So here this is the your simple explanation for question number 12. Now let us move on the question number 13, not 3. So question number 13 is, a cylindrical tank with a diameter of 2 meters is being filled with water from a pipe within a flow rate of 0.1 meter cube per second. How long will it take to fill the tank to a height of 3 meters? So 90 second, 94.25, 9 second, 100 second. So again here you need to apply the concept or think how you will solve such type of questions. So you have 2-3 minutes, or you can take more also if you are not able to solve. So first you just target within 3 minutes or 2 minutes, try to solve this question. Question number 13. Okay, you are telling 94.25 second. Okay, so 94.25 second. Okay, maybe correct. Let me just explain you. So option B, you are telling it is correct. Yes, definitely B will be correct. So the volume of the tank to be filled is given by volume is equal to pi r square h, because it is cylindrical tank, like that, like that. So volume of this is pi r square h. How? Here it is circular, so the area of this pi r square h, and the small area if you will add for height h, so multiply with the h. Okay, so now, so r is given how much, the diameter is 2, so r is 1, and height is given 3, so volume is 3 pi meter cube. Now, given the flow rate is 0.1 meter cube per second, the time to be filled taken by T is equal to what? Volume by discharge. So volume 3 pi and discharge 0.1. So when you will calculate, you will get finally 94.25 second. Very simple question and conceptual question. Very conceptual. Such type of question you can expect in your final exam, in GATE also. So therefore it will take approximately 94.25 seconds to fill the tank to a height of 3 meter. Very conceptual. So now let us move on the next question. Question number 14. Okay. So question 14 is, water flow at a uniform velocity of 3 meter per second into a nozzle that reduce the diameter of 100 mm to 20 mm. Calculate the water velocity living in meter per second, the nozzle and flow living in meter per second, the nozzle and flow rate in meter cube per second. So here you have to calculate two things, one velocity and another one is discharge. So please just try to calculate your answer and try to write in the chat box. So after this question we have one question, then I'll jump to the second one, that is the second set of the questions. So anyway, so after solving the question number 15, 14 and 15, I'll take 5-minute break, you can also take. So then after we'll move with the another set of the questions. I'll give you 2 minutes more for this question. If you are solving, just solve and try to write your answer. Okay, already solved. So you are telling 75 and 0.0236, means you are telling option A. Okay. Here option A is correct. Yes. How? let me just show you the answer or detailed solution. Here you can see. So density of water is assumed to be constant, which is rho is equal to constant. Hence the continuity equation becomes your rho A1 V1 is equal to rho A2 V2. So from here you can calculate V2 very easily, which is 75 meter per second, as we have solved previously also. Now you can calculate discharge also, A1 V1, so very easily. Bit calculative, but we have solved this such type of question. The derivation, not question exactly, the not numerical value was not there at that place. So but we have solved, we have know these type of concepts, the previous questions. So now next question is question number 15, is the last question for this set. We have another set also. So question number 15 is water flow in and out of a devices as shown in the figure. Calculate the rate of change of mass of water dm by dt in the device. So here the option is given. So please just try to calculate your answer in the chat box and just try to write your answer in the chat box, please. Question number 15, very easy question, but you have to understand slightly. So I think the here is the device. So let me just reduce it, so you will be able to yes. So here you can see that. So here you have to calculate. Let me just show you the question. Water flow in and out from the device shown in the figure. Calculate the rate of change of mass. So dm by dt. Here you need to calculate. dm by dt. Slightly conceptual, because entering with your V1, that is you can calculate the discharge because the diameter and this is given, and leaving discharge here you have two, first M2 and Q3. So you are telling option C 38.3. okay. So question is asking rate of change of mass. Calculate the rate of change of mass of water in the device. So now here explanation is given. I will show you. Yes, you are correct for question. Option C is correct. So detailed solution is, we'll see very carefully. the continuity equation with surface across which the water flow takes the following form. So your 0 is equal to control volume, and here the control surface, as we have discussed in the above. So this is dm by dt minus rho 1 a1 v1 plus rho 2 a2 v2 plus rho 3 a3 v3. How? Why? Because you have the three, one inlet and two outlet. Assume the density is constant over the volume, and we use v n is equal to the minus v1, since n cap 1 the volume points out of the volume, okay, and opposite to the volume direction v1. The above equation can be written as like that. The information is given rho 1 a1 v1, m2 already is given because you need to calculate the mass, rate of change of mass. So you need to write everything in terms of the given data, or you can say that in terms of mass, rate of change of mass. This is also rate of change of mass. So here you can see very clearly, and when you will put all the value as you know, so you will get the answer very easily, no issue. So now hope you understand this set. So we'll move on the next set, week 3. So let us solve first this one. So just please try to read answer and try to write your answer in the chat box in between, or you can also take 5-minute break because we have solved the 15 questions. So we need 5-minute break. I am going for water, so you can also go, and then we'll solve the question. Okay, so now let us solve the question. So question 1 is your, let me just put this one, what's happening. Okay, okay, so question 1 is the control system focus on filling the blanks and control volume focus on filling the blanks. You have option A, set of fluid particle, a region of space surrounded by control surface. B, a region of space surrounded by control surface and set of fluid particles. So you have two, option A and option B. Which will be correct for question number 1? So you are telling option A. So control system is focus on the set of fluid particle. Yes, that is correct. And control volume focus on a region of space surrounded by control surface, as we have discussed a lot. So you can just see here the how from the basic concept the question frame in a different way. So similar type of question, not the exact the typing, but based on this concept you will get the question in the coming your assignments or coming exam in NPTEL. So yes, in week 3 your lecture focus on Reynolds transport theorem. That's why we are discussing lot about Reynolds transport theorem, conservation of mass, conservation of momentum. So these are the lectures, 3 lectures. Okay, so yes, option A is correct here. The control system focus on a set of fluid particle and control volume focus on a region of space surrounded by control surface. So this is the correct. Now let us move on the next one. Control volume may be the fixed, movable, deformable, all of the above. So just try to write your answer in the chat box for question number 2. The control volume, okay, you are telling all of the above, means option D is correct for this question. Yes, option D is correct, as we have discussed in the previous set also. So now next question, question number 3, the extensive property and intensive property independent of mass and proportional to amount of the mass. Option B, proportional to amount of the mass and independent of the mass. So you have two options. So just choose which option will be correct about extensive property and the intensive property. As we have discussed a lot, if you will recall your concept, definitely you are able to get the answer. So option B you are telling the extensive property proportional to amount of the mass and intensive property is independent of mass. Yes, definitely, as we have solved the numerical also. Okay, so yes, definitely. So and extensive property is a property that depend on size, amount of a system. For example of extensive property include mass, volume, total energy, and intensive property on the other hand is a property that is independent of size or amount of the system. Intensive property remain the same regardless of the quantity of the substance present. Example of the intensive property include temperature, pressure, density, specific heat, etc. So you can understand the question label. Okay, the next question. The Reynolds transport theorem especially established the relation of physical equation between the system approach to control volume approach. So whether it is true and false. So slightly you can just imagine the question is bit repetitive because the this is your previous year, I think week the 2023 question, 2024 or 2023 question. So yes, definitely it is true. Now let us move on the next one. So here the Renault transport theorem establishes the relationship between derivative of an extensive property of an system and derived of the some property within the control volume. It provides a way to convert between the Lagrangian or system approach to the Eulerian or control volume approach when dealing with the analysis of the fluid flow or other transport phenomena. Remember please. Next question. Question number 5. A system must be a system must always entail the same shape, matter, position, thermal condition. Which option? This is very important, very conceptual question. For question number 5, you can type your answer in the chat box. This is bit different from the other one. Okay, so you are telling a system must always entail the same matter. So this is correct. The same matter should be there. A system can change its shape, position, thermal condition, but always entail the same matter. This is very important. Means the set of fluid particles should not be changed. The meaning of this question. Okay, so here if the okay, so I think we have seen this question, so we'll not go. Next question is question number 7. The momentum conservation principle is based on the physical principle of zeroth law of thermodynamics, Newton's first law of motion, first law of thermodynamics, Newton's second law of motion. The momentum conservation principle is based on the physical principle of what? Interesting and important question. Okay, you are telling option D, the Newton's second law of motion. Yes, the momentum conservation principle is based on your Newton's second law. Force is equal to mass acceleration. Okay, so next question. The continuity equation is based on the conservation of energy, momentum, mass and force. Similar question we have seen. So here mass will be correct, so we'll not discuss much about this. Yes, so this is correct. Question number 9. The continuity equation is valid for only compressible flow, only incompressible flow, both compressible and incompressible flow, neither flow. Which option will be correct for question number 9? For question number 9, you are telling the option C, both compressible and incompressible flow. Okay. Yes, it is correct, both compressible and incompressible flow. Next question is, water jet strike a stationary horizontal plate vertically at the rate of 18 kg per second with a velocity of 20 meter per second. The mass of the plate is 12 kg. Assume the water stream moved in horizontal direction after the strike. The force need to prevent the plate from moving vertically. So you have 4 options. So please just try to calculate. I'll encourage you, just try to write, try to solve first, and then you write your answer. That will be good idea. So for question number 10, just try to draw the diagram and all, so we will get more understanding. Remember, here the weight of plate is also given. So for question number 10, I am waiting. I'll give you 3 minutes. I'll give you within 3 minutes. Just try to calculate. Okay, so you are telling option C, 242 Newton. Force is required 2 to prevent the plate moving or vertically. Okay, nice. So let me just show you the answer, because here you have what? Yes, option C is correct, but here you have one, the your water jet strike at with the your mass flow rate 18 kg per second. Also the mass of the plate is 12 kg. So whatever the force exerted by the your 18 kg per second mass, so that much force we required for protect, but additionally we have the 12 kg weight of, so we need to reduce by that much amount. So okay, let us see how we will proceed for such type of questions. So here it is explanation very well. So the force need to prevent the plate moving vertically is equal to a jet force or water jet force the mass of plate is, if mass of plate is 0 kg, remember, but here is the mass is the 12 kg is given. So the force need to be prevent the plate from the moving vertically, a water jet force minus the mass of the plate, that is 12 kg into 9.81. So, the force need for prevent the plate from the moving vertically, it is the force exerted minus the force, that is the weight of the plate. So finally you will get 242.28 Newton. Very simple question, but you have to be bit analytical, you have to bit think little bit in different way how we will calculate such type of questions. Okay, so next question, let us move on the question number 11. So consider below figure, the diameter of the inlet pipe 1 and outlet pipe 2 of the tank is 5 centimeter and 7 centimeter respectively. I think it is the same question from the previous one. Yes, it is similar one, so we will not discuss much. Now the next question, let us so now question number 12. A flat plate is moving away from a nozzle at a constant speed 5 meter per second. If the horizontal jet of water having cross-sectional area 10 mm square strike the plate with the velocity of 10 meter per second, then the force developed on the plate due to the jet is, you can take the density of water 10 kg per meter cube. So what will be your answer for question number 12? So you can take 2-3 minutes for calculation purpose. Question number 12, very important. Okay, so you are telling 0.25. So means option A is correct for this question. Okay, yes, option A is correct. So how we will calculate the force developed on the plate due to the jet is, here you have formula rho A and V square, the that is the relative velocity square. So V capital V minus small v. So here in the question it is given, so 5 and another is 10. So 10 minus 5 we will get 5. So after the calculation you know very well the things. So now let us move on the next question. So here is the derivation is given. Let me just show you very briefly. A horizontal jet of water with cross-sectional area AZ and the velocity, this is about jet, J is for Z, and the velocity Vz strike a plate moving away from the nozzle, at constant velocity Vp. The force exerted by the jet on the plate is what we need to determine, and the density of water is rho. So assumption here, let us understand the assumption. So the jet is incompressible and has a constant velocity Vz, and when it is exists the nozzle. So this is the assumption. The velocity is, the flow is steady, and the plate is large enough that all the water from jet impact the plates. So remember, and the plate is large enough that all water from the jet impact the plate. There is no loss of water. Remember, after striking the plate, the water does not rebound. Remember, it flows parallel to the plate, not rebound, just flow parallel to the plate. So these are the assumptions. So with this assumption, let us move. So define the relative velocity of the jet with respect to the plate. Remember please, the question may be framed from the assumption of, assumptions. So remember always. So these are very important. So define the relative velocity of the jet with respect to the plate. So relative velocity of water jet as it strike the plate is V relative is equal to Vj minus Vp, you know very well. The relative velocity is crucial because it represents the speed at which water impact the plate. If let us suppose your plate is fixed, means what? The whole water velocity will impact this. If your plate is moving and velocity is also the strike, the jet is also moving, so what will happen? So here you need to work with the relative velocity. Means if the something is fixed, that will experience more force compared to if the plate is also moving. So we have to minus the things. Just remember how we will recall the concept of relative. So always remember. Now, so calculate the mass flow rate of the jet. So mass flow rate is nothing but rho A and Vj, area of the jet and the velocity of the jet and rho. So now, however, for the purpose of force calculation, we focus on the mass flow rate relative to the plate, which is given by mass relative is equal to V relative. So V relative, remember please, because you are focusing on what your both jet and your plate is moving. So determine the change in the momentum. When the water jet strike the plate, it transfer momentum to the plate. Means you have water jet have some mass and have some velocity. Once it strike the plate, the momentum of the plate is transferred to the plate. This is the meaning. and the change in the momentum per second, rate of change of momentum, is what create the force. Means striking. So that is the rate of change of momentum. The force exerted by the jet on the plate can be derived from the change in the momentum. So this is your force, as you know the Newton's second law, change of momentum. So the similar concept here. So mass relative and the velocity is relative, mass per second relative. So since the m dot is the mass flow rate with respect to the relative velocity, so f is equal to rho is a velocity relative, and here because this is what, this is your m dot and this is velocity, so m and vp by vj, this is, and this is also vp by vj, so whole square, remember this. So f is equal to v, your area of jet and density of water and the velocity of jet and the velocity of plate. Sometimes you might be confused whether Vj minus Vp, is it like that? Not. Just remember whole square, because m dot have velocity and your velocity component when you will multiply with the force, when you are going to calculate the force, so mass per unit time into velocity. So conclusion, the force developed on the plate due to the jet is this is. So these are the little bit conceptual, so you can you just focus on how the some formula derived, so maybe question comes from the concepts within the formula also. So now question number 13. Question 13 is, in a normal adult, the average speed of the blood through the aorta, radius r is given in 8 mm, is 0.33 meter per second. From the aorta of the blood goes into major arteries which are each of radius 4 mm. If the speed of blood flow through the arteries is 0.044 meter per second, calculate the number of arteries. So this is very interesting question. So just read very carefully, try to understand the question and try to calculate. So for this question I'll give you 5 minutes. So I am waiting for your answer, please. Okay, so you are telling 30, means option B is correct for question number 13. Okay, so let me just see whether option B is correct or not. Yes, option B is correct. How? Very simple. So, in a normal adult, the average speed of the blood through aorta is 0.33 meter per second. From the aorta, the blood goes into the major arteries, which are each of radius 4 mm. If the speed of the blood flow through the arteries is 0.44 meter per second, calculate the number of arteries. So here, so number of arteries means what? Means, just try to understand. So let us suppose M from your aorta is equal to mass from arteries. Okay, so number of whatever the mass is going from here, and because both are the blood, so definitely your density will be the constant. So mass flow rate and mass flow rate you can write like that. So rho a velocity, rho a velocity. But as you can see here, the these are the means your the radius is 4 mm and this is have the 8 mm. So whatever is coming, it is going in the different, that is a lot of your arteries, because here you can see very clearly in a normal adult the average speed of the blood through the aorta, means one aorta is this, and goes into the major arteries, means number of arteries. So number of arteries here into n. So this n you need to calculate, and this is nothing but rho of blood will be cancelled out, and area pi by 4 into your aorta, which is your 0.008 square, into velocity is given 0.33 divided by pi by 4 into 0.004 square into the velocity is given 0.044. So when you will calculate all this, you will get finally, here it is written 8 because of the both unit is mm, so that will be cancelled out, no issue. So finally you will get 30. Very conceptual question, but you need to remember how you will apply the things. Now the question, next question. Next question is, a circular jet of water the emanating from a nozzle strike a stationary vertical plate normally. A stationary vertical plate, your plate here, remember please, means fixed. The force exerted is measured as 635 Newton. If the discharge from the nozzle is measured as 42.4 liter per second, estimate the diameter of the nozzle at the exit, centimeter. So whether it is 3, 5, 6 and 9. So you have four options and just try to calculate, just calculate and write your answer in the chat box for question number 14. For this question also you have 5 minutes. So we have another question, question number 15 also after this question, and after question number 14 and 15 will close today's session. So I am waiting for the answer for question number 14. You have 5 minutes again. Okay, so you are telling option C is correct. Okay, so let me just check whether option C means 6. Okay, let me just put my mobile at charging. Then I look. So now, so how it is 6? Let me just explain you whether it is 6 or yes. The option C is correct. So you are also correct. So a circular jet of water, circular jet from a nozzle strike a stationary vertical plate. The force exerted measure on means force, whatever you are getting the force, that is your mass into velocity, mass flow rate into velocity. Mass flow rate is nothing but rho av, additionally you have other velocity, so this value is 635. Okay, if the discharge from the nozzle is measured 42.4, so discharge is nothing but means the velocity, discharge by area. So here you can write rho a into discharge by area into discharge by area. Okay, so estimate the diameter of the nozzle. So from here the A is nothing but your pi by 4 d square. This is area. So from here one A will be cancel out and another A will be remain here. So this A will be your pi by 4 into d square. So you can write very easily. Rho is your water, so you can write 1000 into your discharge is given. Discharge is 42 liter per second, means 0.0424 divided by, not divided by again, or you can write here the square divided by area. So pi by 4 into d square, and this value will be your 635. So from here you can calculate, one unknown is there, so you can calculate very easily. So d square will be your, or finally d will be your 6 centimeter. So remember. So this is rho. Or one thing is here, you can see very easily whatever we have gone through. So rho q also you can write, because this is area velocity, so you can write velocity and you can multiply like that. So this is also you can write q and a. So you can go anyway. You solve the answer in your way. So now this is next question, question number 15. Okay. A garden hose attached to a nozzle is used to fill a water bucket with a volume of 37.85 liter. The inner diameter of the hose is 2.5 centimeter and it reduces to 1.5 centimeter at the nozzle. If it takes 25 seconds to fill the bucket of half of its total volume, determine the mass flow rate of water through the hose in liter per second. So whether which option will be correct? So this is the last question for today. So another you have 5 minutes, so please just try to calculate. Okay. So you are telling option A is correct. Okay, nice. So let me just see which option will be correct, whether A will be correct or not. So yes, A will be correct. How? Very simple. Uh, Again, a garden hose is attached to a nozzle is used to fill the water bucket, with a volume of 37.85 liter. Means the volume of the bucket is 37 point, the total volume is 37.85 liter. The inner diameter of the hose is 2.5 centimeter. Means whatever here it is, water is coming from the hose, it is, the inner diameter is 2.5 centimeter and it reduces to 1.5 centimeter at nozzle. So at this location it is 1.5 centimeter. So here is 2.5 centimeter and reduce. This is means bit tapered. It is like that. Okay. If we take 25 seconds to fill the bucket to half of its volume, means within 25 seconds t is equal to 25 second, it fill how much? 37.85 divided by 2. Determine the mass flow rate of water through the nozzle hose. So here you need to calculate m dot. So m dot is nothing but it is your rho a v, or you can rho discharge. So discharge is what? This is your volume, not velocity, remember please. So means meter cube per second, means volume by time you can write. So this is rho is 1000 and volume is 37.85 divided by 2 into second means 2.5. So when you will calculate, finally you will get this is, that is 37.5 and your why it is 25. Okay, so the question is asking about not, okay, question is asking in liter per second, not in the your kg per second. So this give you the kg per second, but question is asking liter per second. So very easy, again the volume by time. So this is your volume 37.85 divided by your, that is half volume in how much second? The second is given 25 second, not 2.5 here, here is 25. So this is 25. So we will calculate, you will get 0.757 liter per second. If the question was asking in kg per second, so you can go with this, like you just multiply with the rho, so you will get in kg per second. If you will multiply with the, not multiply, you will get the answer in liter per second. So this is all about for today. So we'll meet again on the next Tuesday. Maybe the date on the next 2 days, 18 August. We'll meet on the 18th. So thank you for today. Hope you have enjoyed the session. So thank you.